Hi everyone, my name is Zverovich and I will be talking today about the C++20 formatting library. Thank you for choosing to virtually attend this talk instead of Herb's Q&A, which I'm sure is exceptional. I was thinking whether to present this talk in English or Russian, decided to go with English, but keep my Russian accent and exaggerate it as a compromise. So, as we all know, there are four big features of C++20 depicted here. So these are modules, coroutines, concepts, and ranges. And I'll talk about none of that. Instead, I'll be talking about text formatting. So I'm the author of an open source formatting library called FMT, which has been around since 2012. And since 2016, I've been working on a new standard formatting facility for C++. Here you can see the roadmap of the standardization process. As you can see, it was pretty difficult, but in C++20, we finally made it. And so here's an excerpt from the C++ working draft. The formatting library ended up in section 2020, so we can truly say 2020 is a year of text formatting. And like all the best things, format is in the utilities library next to charconf, which is a nice little library for low-level numeric formatting. So in C++20, we'll have a new header called format here, and a set of functions, most importantly, state format, that take a format string. Here the answer is curlies, and variadic arguments. And the curlies are replaced by textual representation of arguments. So in the result here, we get a string containing the answer is 42. So this sounds very familiar. Is it just a printf? So sort of. It's the answer to the question, what if printf was designed in the 21st century? So we want a printf replacement that is safe, extensible, and fast. So what are the features of std format? First of all, it's type safe and extensible, which means that you can add support for user-defined types easily. It has an expressive format syntax based on Python. It is designed for good performance, fast compilation, and compact binary code. It has support for positional arguments, which are useful for localization. It has Iterator support and integrates nicely into the rest of the standard library. It is Locale independent by default. And it supports date and time formatting. So the syntax is very Python-like because it uses a lot of curly braces. Format string syntax can be divided into two parts. The general structure of a format string, which consists of literal text, hello, comma, space here, and then the replacement fields delimited by curly braces. And in the replacement fields, you have an optional argument index. In this case, it is 0, referring to argument name, optionally followed by a colon and format specifiers. And format specifiers is the second part of the syntax, which gives you the presentation of the argument. So here, 10s is a format specifier which says we want the output width to be 10 display units, and we want the argument to be formatted as a string. But note that it conveys presentation, not type, because the compiler already knows all the types. So S can be omitted. And it's a big advantage compared to printf. So So why is it an advantage? You can see from this little example here, there is no legacy. There are no legacy specifiers like LLD or this terrible macro PRIU64 that you would have to use if you were to format a 64-bit integer. Instead, you can just use the defaults, and those will be formatted as decimal integers. So the syntax is semantical. It conveys formatting, not type information. So D means decimal formatting, not decimal int. And you can bring your own grammar and extend the syntax, which is used in particular for formatting dates and times. So here's another example which illustrates in more detail how it works. So we call the format function with a format string and an argument. So we take those, we convert the argument into a string, and we interpolate it into the result, replacing the curly braces, the placeholder. So here's an example with positional arguments. So here we want to format, I'd rather be something or something, and swap the order of the arguments. And so we take the format string and arguments, and we interpolate them in the correct positions. It's very simple. Now let's look at the most difficult example that I could think of. So this is formatting a floating point number using all possible format specifications. So just to illustrate all the different components. So first we have an asterisk, which is a fill character, which is used for padding. Then we have caret, which indicates center alignment. So left is indicated by less character, and greater means right alignment. So this is all borrowed from Python. So this is a new feature compared to printf, which only supports left and right alignment. Then we have the output width in display units, followed by precision of the output, and the presentation. So here we want fixed format. So we can spell it out, and it becomes format 1, 2, 3, 4, 5 in the fixed form, rounded to 2 digits after the decimal point, and pad with asterisk to 10 characters, aligned to the center. So the output is shown here bottom. Or let's again go step by step. We take the format string, we apply first the presentation and precision. So we round the output to 2 decimal digits after the decimal point. Next, we center align and add padding, and then we finally fill with asterisks. So I showed it step by step, but in practice, some of those are combined, so it's all very efficient. And here's an example showing width and precision. So width can either be given in the format string itself, like in the first example here, where we say we want the output to be 5 display units width, and here's the output. So we have 3 spaces, and the number is by default is right aligned. Or we can have dynamic width, where instead of sort of hard coding the width, we refer to another argument here. So, and we again get the same result. And the same applies to precision. So it can be either given in the format string here, .2, or it can be dynamic, taken from another argument, curly is 1, which refers to argument 1. Here it gives the same result. So as I mentioned, we support fill and alignment, which is more expressive than printf. So we can have left, right, and center alignment illustrated on these examples. And we can also have a field character. Again, this is not supported by printf. So this particular output is not trivial to generate with printf. Whether it's useful or not, it's unclear, but there are use cases, and I'll show some of them later. So the API conceptually is very simple. So there are four main methods modular overloads. So the format method that we've seen already, it takes a format string and variadic arguments and returns a std string. Then we have format2, which takes an output iterator, the format string, and again the arguments, and returns the iterator to the end. So it formats everything right through the output iterator and returns you the end. So most frequently, this format2 is used with back insert iterator so that you can directly write into some container. We also have format2n, which takes an output iterator and the maximum size is n here, and again, format string and arguments. It returns you the result object, which is just a pair consisting of the end iterator and the total size of untruncated output. So even if it truncates the output, you can still get the total size similarly as an SN printf. And also we have formatted size, as name suggests, it just gives you the size if you were to format this thing. And it allows you to allocate enough storage. So let's look at some use case more realistic than those little examples we've seen so far. So the example is to format in a terminal a little calendar like this. So the first thing that we need to do is to format a single month. So let's write a function for that. So we have print month, which takes a month of the year, and it returns a generator. So it's a coroutine that prints a single month, suspending at every end of line. So why use coroutines? It just makes simpler combining the columns. Otherwise, we would have to do some nasty tricks. So with coroutines, everything is so much easier. So the first thing we need to do is to print the month name centered. So the January here, as you can see, it's centered. So we can apply our format function with the center alignment, pass the month name and the total width, which is 3, is a size of a single field because we have 2 digits and a separator multiplied by the number of days in the week. It's a little bit, it's not a great code, just a slide code to keep things simple. Then we need to print spaces until the first weekday. So here before 1, we have 2 gaps. And this is what the second piece does here. So we get the first week date, we can convert it into ISO encoding, which basically gives you a number from 1 to 7, subtract 1, and multiply by the field width. And the interesting piece here is that we format an empty string. So why do we do that? It's just because we are only interested in padding. So we can use format just to produce enough padding, and it works very well. Then we have the most interesting part of this function, printing the actual days, so the body of this calendar. So we iterate from the first day to the last day in month using the nice date API, and we output the day number, and then also we check if it is Sunday, then we suspend. Also, I should mention that the result here, well, the Boolean here means whether we finished printing month or not. So, and finally, we print spaces at the end after the last weekday. Again, this is very similar to printing the gap, the padding before the first weekday. It's very symmetric. Again, we take the last weekday, convert it to ISO encoding, multiply by field width. Again, we format an empty thing because we just want the padding. But we do it twice because there can be, in a calendar, there can be an additional row, empty row, because some months are longer. We can see it in the next example. So this is the whole thing that prints a month. Pretty simple. Now let's use it to print the whole row of the calendar. So this function takes the first month and the number of months in a row, and it constructs a vector of generators using this print month coroutine that we had, and it basically invokes next on them until all of them say that they're done. And that's it. Super simple. And the last piece is the main function where we put everything together. We say we want 3 months in a row. We iterate from January to December inclusive with a step of 3 months. We call print calendar row, and that's it. And that's the output that we get. Very easy. There was a little bit of scaffolding that I skipped. So we need to get to convert the month into the name. So we have an array of month names, this little function here. There might be a better way of doing this. And we need a generator. Ideally, this should really be in the standard library, but until then, I just copied it from the CDP reference. So that was too easy. So let's add some Unicode to spice things up. Notice the differences here. We use Russian month names. For example, where are we? We are here. Iyul means July. And also I added emoji just for fun. For example, New Year's Eve is here. Here we have Airborne Forces Day. It's left as an exercise to the viewers to figure out why the Fontan is here, particularly with the international viewers. I'm sure my Russian friends know the answer already. So, I'll only show the differences from the previous example. So the first thing that we need to change is just mapping from month to the name. Just use UTF-8 encoding and Russian month names. And we have a map of special days, which maps from day of the month into a string. Why we need a string? That's easy because emojis consist of multiple code units. We cannot use char, or even if it was a wide encoding, it would still not be enough to use one code unit. So we need a string. So here we have some holidays and other special days, Unity Day, which is dedicated to game developers. So we have a little bit ugly hack here around Victory and Russia Day. The problem is that iTerm has a bug where it combines the medal emoji and the flag emoji with the next character. So hopefully it will be fixed in the terminal emulator. Until then, I just added an extra space so that everything works correctly. And we need to modify our loop that prints days. So again, we iterate over this, but we also additionally look up in the special days map for year, month, day. And if it's a special thing, well, if it's not a special thing, we do the same as before. We just print a number. Otherwise, we print the emoji. We don't do anything special. Sorry. For tautology, and that's it. So it works if your system happens to be capable of displaying UTF-8, or it works on macOS and most Linux systems. On Windows, you'd have to compile with /UTF-8 flag, and also set your active code page and do other ugly things. And still, the default console won't be able to render emoji. Fortunately, they are working on a new terminal that I think that addresses some of the issues, and it is Unicode capable. So STUD format will provide full support for date and time formatting, including all calendar types added in C++ formatting. So here are a few examples. As I said, it integrates with chrono. You'll be able to format durations and dates using strf time-like format syntax, but you don't need to call this separate API. It's all integrated using the extension mechanism. So the defaults are pretty reasonable. So for example, if you have a duration 42 milliseconds, you pass it to format, it will give you 42 milliseconds, reasonable. Default and usual for C++. Or like strf time, you can have something like 10,000 seconds. You can say, I want to convert it and format it as hour, minute, second. That's how you do it. It also supports dates. So here we have this very nice syntax from the new chrono date time facility, and it formats it using ISO standard, which is the correct way to format a date. Again, the correct default. So STUD format supports user-defined types, and the easiest way to make your type formattable is by reusing an existing formatter. So for example, you have this color enum class that you want to format as a string, red, green, blue. So what you need to do, you need to provide a specialization of STUD formatter. It's sort of similar to hash extension point. So instead of writing parse function ourselves, we just inherit from formatter of string view, because we just want it to be formatted as a string. And parse is inherited. So we only need to define the format function, which takes your object and is something called format context, which is just an output iterator plus access to other arguments, and optionally the lazily constructed locale. Lazily because we don't want any locale overhead for the default case. So this is very fast. So what we do in the format, we map the enum values into names, kind of what you would do if you were to implement off-stream insertion operator. And then you just delegate to do all the work to the base formatter of string view. And this automatically gives you all the formatting facilities, all the mini language supported by string view. For example, you can say, I want the output width to be 5. Here, pass your enum value. You get it padded with spaces. This is the easiest way, but you can go wild and define your own formatting mini language as in Python. So everything is possible. It's just a little bit less dynamic for efficiency reasons. So another thing with respect to extensibility is that stud format makes it easy to handle multi-component objects. What does it mean? Let's look at this example. So if we were to format this object here, the second Sunday or something, which obviously consists of 2 components, Sunday and this thing in square brackets. And with the usual implementation of the insertion operator, what you do, you insert the first thing into the stream, you insert the second thing, and you return the stream, right? This is how I would implement it, and it's almost went to the standard like this. So if we do this and then apply the manipulators, then it would be misaligned. So it would apply the IO manipulators only to the first thing. Actually, it's more complicated than that because IO manips are inconsistent. Some of them apply to the first thing and then the reset. Some of them are sticky. It's a little bit strange. With format, it's extension point. It's more natural to treat this thing as a single unit. Although you can still make the same mistake, but it's less likely. And so you can rewrite this whole thing as format to the left with width of 8 and give this argument, and it will correctly align provided the correct definition. So we prevented the first thing from happening, so this is not the case in 20. This was fixed by defining insertion operator in terms of stud format, which was a nice drive-by fix. So far we looked only at format which returns a stud string. You might argue, oh, it's not efficient because allocation and such. So we can completely avoid dynamic memory allocations using format to and format to n. And this example illustrates how to do this. So we have a stack allocated buffer here, and we call format to n, pass a buffer and its size, and we just say we want to format this integer as the default kind of silly example just to illustrate the API. And the result object will give you the end iterator, which is actually pointer in this case, and the size, total output size, which will be 2. Note that it doesn't append a necessary terminating 0. You can do it yourself if you want. So this replaces printf and sn printf. You can get output size with formatted size and preallocate things. What about number formatting? It is defined in terms of 2 chars, which greatly simplifies specifications and has nice properties such as round trip guarantee by default for floating point type. I think I should thank Jihao Yuan who suggested it. So for example, here we have 1/3 in floating point, and use the default formatting, it will give you 0, 3, 3, 3, 3. So that if you parse it back, you get the exact representation, binary representation. Unlike with sprintf, where if you do the default, it will give you the default precision of 6. which is a magic number. I don't know where it comes from. It doesn't use locale by default, and as I said, provides round-trip guarantees. But if you want, you can use locale as an opt-in. So the default is locale independent because it gives deterministic output and better performance. Deterministic meaning that if you want to write an XML or JSON, you don't want your floating point numbers suddenly have commas instead of points when someone changes a locale from another thread or a user has a different locale. So you want a deterministic output, and that complies with the XML or JSON specs. You only want locales when you display something to the user. So they are supported as an opt-in through separate format specifiers for numbers. It's L. So here's an example. We construct a Russian locale, and we call an overload of format that takes a locale. We say we want to use this locale, and we pass a number, and it will use spaces as 1,000 separators. So binary code bloat can be a big problem in C++ if you're not careful enough, particularly with variadic templates. And std format is designed specifically to avoid this problem. So let's look at this example. How many instructions do you think it will generate? Unfortunately, I have a virtual audience, so no one will answer. No one will hear me scream when we look at it. But if we use Net the Explorer and plug this thing here, we get this output. It's actually not everything. This is the full output, which is way too much if you ask me. So it's around 150 instructions. So this is a silly example. You might argue we are converting an integer into a std string with the ostring stream because the standard library has a nice toString, well, by some definition of nice toString function that does that for you. But it can totally be a part of a bigger, something bigger in your code. You might want to format some text and then have a number as a suffix. So, and then you get all this enormous bloat. So how can we solve that? Let's look at the same example now implemented with FMT format, which is an implementation of C++20 std format. And if we plug it into Godbolt, we'll get this. As you can see, we have only a handful of instructions now. What's even more interesting is that V format does not say anything about int. So here's the V format, which is a type erased function. It just takes a format string and something called format args. It completely eliminates variadic template bloat that we would see if we did this naively. And the call sequence is very efficient too. We just put an array of arguments on stack, and in the common case encode all the type information in a single integer. So as a result, the binary code is comparable to that of sprintf or printf. So now let's look at the performance. It's a little bit hard to talk about performance because standard libraries haven't implemented this yet. So we have one implementation in FMT, but the optimizations are built into the design, so we can talk about that. So the new formatting library is much faster than iostreams by design due to the following ideas. It has stateless APIs, so everything that you need to know about formatting this specific thing is encoded in a format string and arguments. There is no state passed around through the stream object, and it opens a lot of optimization. Secondly, it's locale independent by default. Then we have fewer function calls, as we saw in the example I just shown, and we can have zero allocations with format 2 and format 2n. In fact, we can even have zero allocations with format because of, in some cases, because of small string optimization. So if we have just a small integer we call format, it's likely that it will fit in the small string. So it's also faster than stdio by design, which is a higher bar. So why is that? This is a simpler format syntax, no legacy specifiers. Remember, in the beginning of the talk, I showed that all these macros and things like LL go away. So these are so format string is easier to parse. Then you need to care about fewer options in your during formatting as well. So again, we are locale independent by default. And the last item is actually counterintuitive. So the new facility has more efficient argument handling. You might think that varargs are very efficient, as C and everything is passed in registers, must be super fast, but in fact, because it has these two levels, so printf will put a bunch of things in registers or on stack and then call vprintf, which will reshuffle some of that stuff, and then you have a third level in vprintf itself when you need to deal with positional arguments. So the call sequence is not optimal for positional arguments, so they have reshuffle the arguments again. So passing format as a string view is beneficial too, because you can then check the size and apply a small format string optimization. So let's look at some benchmarks. As an example here, we use the Boost Karma integer formatting benchmark. So we are looking at FMT's implementation, and what it does, it formats a bunch of randomly generated integers with a semi-realistic distribution. Excuse me. So, and I should explain that so R here means runtime handling, runtime parsing of format string. C here means compile time processing of format string. So currently in the standard, we only have runtime format strings, but the design is, it's all designed in such a way that we can add compile time format string processing later. And I plan to write a paper about it for C++23. So, but even with runtime format string handling, you can see that we can have several times better performance than sprintf or ostring stream. This is on macOS with Clang and libc++. So even surprisingly, format is slightly faster than toString, but there is no reason for that to be the case. I think it's just some missing optimizations in Studs toString implementation. Once we have compile time string processing, we can be as fast as 2 charts, as we can see here. Again, there is no reason for one to be faster than another. It's just an artifact of different algorithms used. So this is pretty much the same, but on a different platform. The hardware is different, the operating system now as well. Here it's Linux with GCC and libstd C++. So it's a little bit more balanced in a sense that the difference between the highest performing and lowest performing method is smaller. And std2string it performs a little bit better, which is what you would expect. So the runtime format string processing is still shows very good results, much faster, up to 2 or 3 times faster than stdio and ostring stream equivalents. And note that here we have format returns a std string, and it's still faster than sprintf, which writes into a stack allocated buffer. That's because we don't do any allocation, we just use a small string optimization. And in the future, it can be even faster because we can, if we can avoid, if we can write directly into std string, and in C++23 we'll have an API to do that. So here is the same data, but in table format, just to give you the idea what the actual numbers are. So with format string compilation, we can have like 100 million integers per second converted. This uses a stack allocated buffer as same as 2chars. With runtime, format string processing, you can also have pretty good results, 10x faster than ostring stream on macOS with libc++, and about 2x faster, 2.5x faster on Linux, where those are better optimized. Standard libraries probably better optimized a little bit. So this is a benchmark for floating point formatting by Mila Ips. It's called D2A benchmark. I ran it on macOS some time ago, and it shows that with format 2, so here we can get better performance, like order of magnitude better performance than printf or string stream, and even better performance than double conversion, which is a library specifically written for floating point to binary to decimal kind of formatting. So we can expect this performance to be in the standard library implementations, and so everyone can benefit from that. In addition to that, here we have round-trip guarantees. So this is a lighthearted diagram showing that we can have much higher performance with std format compared to stdio streams, but FMT still provides a little bit more features, such as compile time format string checks, format string compilation, container, tuple and range formatting, named arguments, a little bit I/O. So hopefully over time we'll incorporate these improvements in the standard library, and the design fully supports all of these improvements. So I'd like to thank the date library and its creator Howard Hinant. I used it in the calendar example because the calendaric APIs are still not available. Well, we're still not available while I was doing the slides. Also, the calendar example is inspired by the These component programming with ranges, which is a nice post or part of the documentation. I don't know, with a link here. And of course, excellent talk by Eric Nibbler, ranges for a standard library, which I encourage you to watch. I butchered it a little bit, and so it's not as elegant, just to fit it into the slides and to illustrate the formatting APIs rather than the ability to do it in a more declarative fashion. So some promotion, shameless self-promotion. I encourage you to take a look at the FMT library, which is available on GitHub. Here, the documentation has moved to FMT Dev website. It has hundreds of contributors. It's used in many open source and proprietary projects. It's available in pretty much all package managers of Linux distributions, Homebrew, Chrono, VCPKG, available on Godbolt, you name it. So some of the notable projects that use the library are MongoDB, PyTorch, C*, Windows Terminal, which solves the issue that I mentioned earlier with Unicode, GF8 support on Windows, SpeedyLog, which is a great logging library. So PyTorch and Windows Terminal are in top 10 C++ projects on GitHub. And I want to end on this quote from Murakami, which I think is on C++. It says, "Suffering is optional." I hope that with C++20 std format, we demonstrated that we can provide modern, convenient APIs on par with other programming languages. We can also have good defaults, so we don't need to suffer. And I think we are ready for Q&A. I finished a little bit early, so we have more time for questions.
Yeah, cool. Thank you, Victor, for a great talk. It was super interesting to listen. And before we move to the questions from the chat, from the audience, I have a couple from myself, if you don't mind. So,
sure.
It's kind of it's more clarifications probably. So in std format C++20, there is no compile time format check.
Yes. Everything is. Yeah. I can elaborate on that. So in the timeline of C++20, there was no good way to express the high-level kind of API. We didn't have const eval functions or and the kind of what is called the ability to pass non-time template parameters came pretty late in the cycle, so we didn't have time to provide to get a good implementation experience and provide this top-level API. However, we built into the design the ability to provide it later. Specifically, the formatter extension point is split into two parts: the parse function, where you parse format string, and the format function. And the parse function can be const expr. And if you do that, then in the future, we could have compile time checks, and more advanced thing is format string compilation.
Cool, thank you. And the follow-up, sorry if I missed it, I was kind of answering part of the chat question. So you mentioned that in C++23 we can be faster. Is that what you just described?
Yes. So my plan is to get some experience with format string compilation. It's available currently in the FMT library as a sort of experimental feature, but I think in the next release, it will be graduated into sort of production level feature, so people can go and well, at least the API will become stable. You can go and play with that, and we can. My plan is to write a paper proposing format string checks and format string compilations for 23. Now that we have all the some of the facilities in the language.
Cool, thanks. And FMT itself, what standards it requires? What you're based on? Like something?
So one of the main goals of the library is extreme portability. So the current version requires a subset of C++11, but we also support C++98 through the older FMT 4.0, which is no longer actively developed, but it's still maintained.
So suffering is not optional.
Well, the suffering part moves from users to the developers of FMT. So yeah.
Well, it's C++ now. We all know what's what. Cool, but still, so you based FMT on C++11, and it's actually possible to build this compile time checks on top of C++11.
No. So this, in C++11, it's not possible. So this is conditionally kind of compiled feature. It is possible to do in C++14. So the minimum requirement for that is that we need some sort of compile time strings. So in C++14, we can have a const per lambda hack by Michael Park and have it using macro, which is sort of ugly. In C++17, so current requirement for compile time format string processing is C++17. We still need to use this const per lambda hack, but at least we can also use if const expert to implement parsing in a less crazy way and suffer less. With 20, we don't need any macros. We can use a const-eval function or UDL, maybe. UDLs, user-defined literal.
Cool, thanks. I think it's time to move to questions from the audience. So the first question is, why partial formatting is not supported? Meaning that it's okay to pass excessive arguments to format function, but not vice versa.
So it's okay to pass extra arguments because it's basically equivalent to having an unused arguments in your function. So at most it's a warning. People ask it a lot. There are some use cases for that. And it's also, if we were to implement it, that it would add a lot of overhead for very little benefits. So people have lints for that. As for the other part, why don't we have partial formatting? I don't remember people proposing it. There might have been some issues, so that's probably the main answer. I didn't see a good use case so far.
So if the author of the question actually needs it, he can go to GitHub and
yes. Just to add to that, I want to add to that. So so it's basically based on similar facilities in other languages. So we have like decades of implementation experience, and I don't think any major facility I'm aware of doesn't provide partial formatting. So it would make more sense for things like a template engine like Mustache. We don't want to turn it into like super or expressive mini language. Although through the extension API, you might be able to do that. So just wrap it in your types and have the whole have another domain specific language, which I wouldn't recommend, but you can do that.
Okay, cool, thanks. Another question is how to format stud optional using stud format.
So right now, I don't think we support any standard library types other than chrono. Yeah, I think mostly chrono. In C++20, we were too close to the deadline to have those. There is a separate paper that provides formatters for library types. I don't remember if it includes optional. It has support for complex. I think something unique pointer, shared pointer, some file system stuff. We could add formatting of optional in 23. Yeah. Papers are welcome.
Well, the question is from Anton Paluchin, I think. It's not new for him, so you heard it, Anton. Prepare another paper.
Yes, okay, thank you. Anton is a very prolific paper author, so I'm sure he has all the experience to do that.
Okay, so can you choose some other type as a return type of stud format?
Can be other type. I'm not sure what that means. You can, yeah, I'm not entirely sure what that means. The stitch format always returns a stitch string. So no, I guess. You can write your own function, which is almost exactly as format. All the APIs are there. So you can have this type erasure mechanism that I described and reuse code bloat in your code and write exactly very similar functions, but they do different things. For example, have a logging function, which has very nice small per code binary code using this facility very easily. You can re-implement std format in like a few lines of code if you want.
Cool. Thank you. That's super cool. The next question is, will named arguments from FMT library will be available in stud format?
That's a good question. I'm a little bit skeptical because at this moment some people find them more of a hack. So the way that work, I didn't cover them in my presentation, but for the viewers, the way they work is that instead of an index, you have a name, and then the argument itself is wrapped in a call to fmt : arg together with the name. So the value and name are wrapped in arg call. So it's a little bit of a hack, I admit. It uses only standard facilities, but it's not super nice. There is even a more hacky UDL-based version. So if we have a standard way to pass named arguments, then we could have it in the standard easily. Well, depending how it works, if it supports like kind of runtime access to the name, or some kind of reflection-based way to access the name. So I think in its current form, there would be too much opposition.
Yeah, that's a good thing that you cannot, move everything to the standard library.
Yeah.
Otherwise, we'll have something like string.
Yeah.
Okay.
Also, more users for FMT, I guess. And those who need named arguments use FMT.
Yeah, that's true. It's always true. Next question is, what is format context from the slide 62?
Oh, okay. Let me open
Of
the
course, yeah.
slide.
And we can ask our engineers team to show slides to our audience.
So format context is just an object that gives you the output iterator where you should write the output, as well as access to other arguments. So for things like dynamic width and dynamic precision, you need to go and reach out and grab the value of another argument. In most common case, you don't even care what format context is. You either pass it to the base formatter or just use the output iterator. Just take ctx.out and you write to it whatever you want. It's mostly for advanced things. So what else? It also provides the locale. As I mentioned, it's lazily created because we don't want locale overhead. It was a big theme to make everything locale independent by default. Even constructing the locale can be expensive, so it is not constructed by default. So you just have no overhead in the common case, and only if the user says, "Oh, I want to use the locale," you reach out into the context. You say, "I want to format using locale," you can get it. At which point it will be retrieved and constructed.
So as far as I remember, at some Unix and at Linux systems, Locale will be opening files, right? Like something. So it's really expensive.
Yeah, it's kind of expensive. It's already, if it is already created, I don't think it will open file, but it has this reference counting mechanism, which is thread safe, and it has some synchronization overhead. Also, it's a virtual function-based the API, so you pay there as well. So you want to avoid it for the common case, but when you need it, it's not that super expensive, because the use case for locale, people always say, "Oh, locale is super slow," but because they're misusing it for things that shouldn't be localized. For example, when you write JSON, numbers in JSON, you don't want to go and have your comma instead of point because it's broken JSON. So you shouldn't use locale there, but you should use locale when you display something to the user. And when the user is a bottleneck, you don't care about the performance, like 10x slower, sure. You don't show gigabytes of data to a single user. Or, well, if you have like many users, you might care about that, but locale can be optimized.
Yeah, people are slow, of course. So, and the actually next part of the question is if it makes sense to use some custom format context. Is it possible if the user required for some reasons?
No, format context is something provided to you by the standard library. It's just an API for you to get the information about where you are in the formatting process and how to additional things like extra arguments, where should I write to. It doesn't make any sense to have a different format context. If you need a different context, for example, if you have a different iterator, the standard library will provide it for you. That's why we have it as a type name. Well, actually, no, that's partly true. There is one case where you may want a different format context. If you have a completely different format string syntax. Let's say you implement printf syntax with percent and everything. Then you might have printf context. And that is possible. In fact, FMT has that. It has printf context, and it reuses almost like 90% of the formatting code between format and printf implementation, and it has this different printf context. But it doesn't make much sense in that case either, because printf is not extensible. How do you even find where to stop parsing of your thing? So there are theoretical use cases, but I don't know about any practical one.
Cool. Well, for most of us, C++20 is theoretical.
Well, you can use coroutines. I used coroutines in this example, and it worked perfectly.
Yeah, but I mean, in production and everyday life, of course, in pet projects, probably we can use it. But
you can use it in slide code.
As a person from the embedded world and from GCC 4.8 perspective, I can tell you that I can only dream about like C++20, even C++14 for me. It's like something I can only dream of. Sorry, I got a bit distracted by my suffering. So the next question from Sergey. Will FMT support dynamic lists of named arguments?
It already supports that. We're glad you asked. So someone, I forgot.
Format.
Oh, FMT, yeah. Was the question about SID format?
No, it's about FMT, but of course I'm also interested in STUD format.
So FMT already supports that, and there is nothing preventing the same from happening in the standard library. Just someone need to write a paper. It might be possible to implement it in userland. I need to check, because basically what you need to do is construct an array and put arguments in there. So one kind of it's probably need to be in the standard, because you don't know how the actual implementation of the type erasure mechanism work. So the standard hints about it in the specs, but it doesn't provide the actual APIs to do this. So yeah, it will need to be in the standard library.
So waiting for the next paper, right?
Yeah, I think it's lower priority though than compile time thing, because we can give compile time checks.
Okay, sorry, go on.
Good. I mean, with compile time checks, you get so many benefits. With this one, you get a little bit of benefits. So one interesting use case, you can, for dynamic format, for dynamic arguments, is that you can write a bindings for other languages. So you can actually have std format used from Python, and then you kind of have this inception thing going.
Yeah, cool. But yeah, I was saying that the author of the question, Sergei Solovyov, can write a paper probably.
Yes, please.
Yeah, there is Anton to help. So at least we can go to studcpp.ru, studcpp.ru, the website, and make a proposal.
Yeah, we already have an implementation experience, so part of the work has been done.
Yeah, of course. That's always much easier. So the next question from Anton: what if buffer for format 2m is small? Is not enough?
Okay, let me go back to this slide. Where was it? Here. I think this is the slide. So if it is small, then it will truncate and only write as much data. For example, if we have a buffer of 1 character, which is a silly example here, it will just write 4 and give you so out will point to the end of the buffer, well, 1 past the end, actually, and sides will give you 2. It will give you the total output size as if it was not truncated. So this is exactly the behavior of SN_printf, because we want people to be able to transition without too much difficulty, even though the syntax is different, but it's strictly more powerful. So you can even write a automatic conversion sort of mapping, automatic refactoring tool that does it for you.
Sounds great. And while we can see slides, you have this small example and slide 69 of the string stream. And you mentioned that it's silly, but I was just yesterday fixing this code that actually do hex format this way. So it was just the most obvious way for the author for my colleague to format number to hex. And I was surprised that it's actually, it's really hard to find in the standard library to find something that will produce you standard string in toString, but with hex. No, so
now you can do it with 1 line.
Yeah, in C++ 20.
Well, now, in 10 years.
Yeah, probably on some embedded device it will be like this. So you mentioned that the way your path to synthesization was a bit curvy. Can you? We have two more minutes. I think that's the last question. It's just so it's not non-technical. Can you say what was the main obstacles? What was the idea to go to this way?
So it was curvy in a sense that it was long, and there was a lot of feedback because people have a lot of opinions about how formatting is such a trivial sort of conceptually task that everyone has ideas how it should be implemented, and there was a lot of good feedback actually. So it benefited greatly the FMT library. So all the Iterator support came from standard committees. So it improved the API dramatically and made it simpler, which is unusual for standardization process, made it more powerful. So I don't know. If you go back and look at my talk in 2017, CPPCon talk, the API was a bit ugly. So there was this buffer concept passed around, and it was kind of ugly, more verbose, and in some cases even less efficient. It had the type erasure built in, but we actually don't need to expose it in such a direct way to the user. It can be like underlying mechanism is sort of type erased, but users don't see that. They just have iterators, nice APIs, high-level APIs. It looks like another standard library method. So format to n actually almost exactly look like copy and copy n or any other pair of functions.
Thank you, Victor. It was amazing.
Thank you. We will continue in Zoom.
Okay. Bye, everyone.
Thank you very much.